What's up everyone, and welcome back to the Comps channel. For today's video, we'll be taking a look at this awesome little ultra-thin Meshtastic device from Seed Studio. Also, I've been wanting a way to do range tests without having to mess with the CSV files, upload them to Google, specify what fields to map out and all of that. So I've made the process a bit easier now, and you no longer have to upload to Google and can do it all on your machine locally. So join me as we take a look.
Two here, Morse on guard. Aircraft 4 miles west of Bainbridge Airport.
Okay, I'll be back in 6 seconds.
We're approaching a restricted area. Restricted area is 1 mile west.
Before we get into it, Seed Studio reached out to me and sent me this new device called the SenseCAP T1000-E. Now the E is important because that is the Meshtastic version. They've also sent me another Meshtastic device, which we'll be getting into in a video soon, so be sure to subscribe if you haven't already done so you won't miss out on that. But let's go ahead and get into the first topic of this video, which is the SenseCAP T1000-E. First, as you can see, it's ultra thin at 6.5 millimeter, and the dimensions are about the same as a credit card. Mine here is see-through, and we can see a bit of the internals, which is nice because I don't want to take this apart. And the reason for that is this does have an IP65 rating, which means it's water resistant, so it should be fine if you get caught outdoors with this in the rain. Now, it isn't completely submersible like the ham radio I reviewed in the previous video, so sadly there won't be a soothing creek water test at the end of this video. Looking at the back of the device, we can see we have a 750 milliamp hour battery, and then these 4 contacts we see here are actually the USB port, and it has magnets, so the USB cable, which also has magnets, just snaps into place like so. Then looking at the front of the device, we have a piezo buzzer, which allows the device to make sounds, an LED light, and this circular area on top here is a button. Then of course we have our board with all the circuitry and the radio, and this device is NRF52 base, which means that it's very power efficient, so we should be looking at days of usage instead of hours. Then on the top left here we can see the device's antenna. Now this device is pretty small and the antenna is obviously pretty small, but that begs the question, how will this device perform? For that, we'll be using Meshtastic's Range Test feature, and we'll compare it to the WizMesh Pocket from Rack Wireless. I did a video on the Range Test feature ages ago, and there's been some slight changes to how it works compared to what is shown in my video back then, so I'll be doing a new video on it soon using this new tool. Now, most people tend to upload the CSV file to Google's mapping tools, specify what the relevant columns are, then specify a color scheme based on SNR and so on. A number of people have mentioned wanting an alternative, so I've come up with a Python script that'll allow you to just put all of your range test CSV files in the same folder as the script, run it, and then you'll be presented with an HTML file that automatically displays the range test with color-coded data based on a signal-to-noise ratio. Not only that, it'll allow you to display multiple range tests using these checkboxes we see here, so we can easily compare range tests. Then above that, we have a number of selectable map options. And I'll include a link to this tool in the video description. It's pretty straightforward to use, but I'll also be doing a video on doing a range test using this tool for those who may be unfamiliar with using Python scripts or doing range tests. So for the test, I started the range test and drove around a bit with the WizMesh Pocket mounted inside my vehicle. Then I performed the same test with the new T1000-E mounted in the same location. Now I did 2 range tests for each device to get more data points, so I have a total of 4 CSV files that I provided to the script that we can see listed here with these checkboxes. Now I did these range tests from my home node, so I'm just using this blank background instead of a map for privacy reasons. So the colors of each marker changes based on the signal-to-noise ratio. Green is good and red is bad, with varying colors between those. Now I do get what appear to be inaccurate signal-to-noise ratios in the CSV files, like these extremely high ones, even though they're not close to home. I still wanted to display these readings on the map since the device made contact, but I've set these to have a gray marker. Now, if we look at a lot of these points between the two devices that are close together, we can see that the new T1000-E is actually performing pretty well considering its size, and it's not too far off from the WizMesh Pocket's performance. Now, I didn't have enough time to do tests too far out and just wanted to get a general idea of how this new device performs, and I've been pretty impressed with it so far and look forward to using and testing it more, so be sure to stay tuned for that. If you would like to pick one up for yourself, I have a link in the video description below. If you found this video helpful, please be sure to give it a thumbs up and subscribe if you haven't already done so you won't miss out on any of our upcoming videos. Thank y'all and have a good one.